We're a minute past now, so I'll start. Welcome to this presentation about container queries. My name is Rune. I'm the tech lead for style and fonts in the Chrome rendering team, and I'm joined by Ian Kilpatrick, who is a tech lead for layout in the same team, and he'll be able to answer complicated layout questions if they should come up. So container queries, this is a project that we started almost a year and a half ago now. So to give an introduction, for some years now, we've had media queries, which is a way to do responsive designs where you adapt your design and content to the size of the screen, either a mobile phone or your desktop, and give different experiences based on screen size. But this is not always what you need if you have a separate component inside your page that you would like to style based on how much screen estate that component is given. So sometimes your component takes half the width of the screen, and sometimes it covers the whole screen, but you cannot use media queries to do that. So in light of that, authors have been asking for what we call container queries, where you can, instead of querying the viewport size, you can query the size of your component that you're creating. So here's an example. Yeah, basically what I said, highly requested features from developers when we've been doing dev set queries. Responsive design based on component size, and here's an example of how the syntax has turned out in the spec. You query a container based on its size, and you apply specific styles to your component and the children of your component based on that size. And here's an example. I'm definitely not a great web designer, so this looks pretty ugly, but this is an example of how I would do use container queries to style this card on myself based on the width. So to the right, I have space for floating my image to the right and having some content text below my name, and the component version to the left is I don't have room for the text, and I've basically styled it differently. So container queries have been requested for many years, but it has been seen as a difficult or complex thing to do, because how that this requires the layout of one element affecting the style of its descendant, and being able to feed back that up the tree if we're not sure to make sure that we spec it in such a way that it will give us a predictable and interoperable layout. So container queries will basically introduce a loop in the rendering pipeline where you do the style, you do the layout of your component, and then discover that, well, the width of this component is of such a size that we actually need to redo the style for the elements below our component, and then potentially have box tree and layout changes. So the first step is to make sure we can write a specification to be able to implement this interoperably and make it possible to implement it in the web engines at all. Here's an example of what the basic problem is. This is a container which just contains an inner element with text, and the container is sized based on the intrinsic size of the container. And we query the container and change the font size of the inner element based on the container size. So what would happen first here is that we size the text based on the font size of 100 pixels, which means that the intrinsic size of that text will expand the width of the element, like we see in the first rendering of the text, which means that the width is wider than 100 pixels, which means that the container query will trigger, and then we will reduce the font size to 10 pixels based on that query. But then the width is actually narrower than 100 pixels. So we get a circularity here. So we cannot simply implement container queries without any limitations. And one way to solve this is to introduce containment when we establish a container for size queries. Containment is something we already have in the CSS contain spec, where we can apply size, layout, and style containment on an element. It's introduced for performance reasons, and being able to do layouts without affecting layouts on the outside of your element. Size containment is about intrinsic sizes not affecting the size of the element itself. And style containment is basically about counters and quotes not affecting counters and generated quotes outside of the style contained element. So this is something that we thought that we needed to be able to implement container queries at all. The problem with that is that size containment is very strict in that very often you would like to have your height of your container being sized by the contents of that container. So basically use intrinsic sizing to expand that component. Otherwise, you would have to use specific predefined sizes to your container, and that would not cover all the use cases that authors need. So introducing inline size as a separate containment type has been considered, and there's been a lot of discussions back and forth. Can this actually be implemented? Will it work? Will there be a lot of cases where we cannot predict the outcome, etc.? But we have been speccing it in the CSS working group and made it possible. So below is a rendering of what it would look like if you only had size containment and you had an auto width for a container and auto height, and have text inside that would not expand the container because of the size containment, which would just collapse the container. So inline size would allow that container below to extend based on the text. One thing that was discussed for a long time, and we ended up specifying it as for inline size containment, make sure layout is always moving forwards, and that when we have when we have certain constraints on the outside of our container, they can change, but we should never try to position something at the same place that we have tried to position it before. This is an example where you have floats. The blue, pink, and the orange rectangles are floats. First, we start trying to, and the X is in a container which has which is a block formatting context, so it doesn't, so it has to fit within the floats. First time we tried, we have a text which is too large to fit in the first space between the two first floats. We move it down, and then there's a container query that reduces the font size of that X. in that case, it will fit beside the orange float, but it will also fit between, now it would also fit between the blue and the pink floats. But if you move it back up, the font size would be large again, and we would end up in the loop if we tried to fit it in the same position that we did the first time. Style containment. Here's an example of how that could be a problem if we didn't apply style containment. Style containment for counters works in a way that a counter reset or increment inside the style contain element would not affect the counters outside of that container. So if you have a query container here to the left as one flex item, and then another flex item to the right, which uses a generated counter, and then the counter inside the container would increment the counter, you could have the flex item to the right take up so much space that it would change the size of the container, and therefore change the styles inside the container, which would then have a different counter increment, which would mean that the state would flip-flop between the two different cases below. So to summarize what we needed to do spec-wise, we had to introduce a containment-inline-size in order to cover all useful use cases. We have introduced the two properties, container type and container name, to establish a query container. We apply size, layout, and style containment, or inline size containment for these container elements. And we introduce an at rule that you can use to query containers. Then we'll take a look at the implementation details. So in order to make it work with that loop in the rendering pipeline that I showed earlier, we need to interleave style and layout in some way. That is, it is actually possible to do similar to what we do with resize observer, that you run a full style update and then run a layout update, check if anything changed in size-wise, and then do a full style update again. We decided not to do that because of performance issues, and also we thought it would be easier to get the predictable results doing an actual interleaving of style and layout so that we re-enter style during layout. So the approach is to first start with the style recalc in the pipeline, and when we reach containers that we know we will reach again during layout, skip the recalc for the subtree, and store the current state for the recalc, and then resume at layout time. Also, elements which depend on container queries are marked in their computed style so that we know which elements that we need to invalidate when the container size changes. So some of the implementation challenges we've had, there are a bunch of invariants and invariant contracts between style and layout in the code that we needed to make sure that with the D checks are updated, that we can actually mark style dirty during layout, marking layout dirty during layout because we need to mark for layout in the container subtree while we're inside layout. Allow style recalc during layout, and allow box tree modifications during layout. These box tree modifications and and marking layout dirty needs to happen inside the container that's being considered, so it doesn't mess up the already in progress layout of the outer elements. Also, a layout ng not being finished has been a complexity that we have had to handle during the implementation phase. Yeah, so this is, I've already visited most of this. Style recalc as usual. Skip style recalc, that's true. So subtrees will be left in the style dirty state when we skip subtree recalcs and resume later, and that's definitely something that has to be handled in the sanity checks and D-checks. And for containers, we store a query evaluator that keeps track of evaluation results from previous evaluations and figure out if the evaluation changed during layout. Now for the layout implementation, as I mentioned before, we decided to only make this work in layout ng, and that's partly because it's a lot easier to do it in layout ng, and also partly because layout ng will soon be fully shipped. There's a single entry point in ng block node layout, which made this quite easy for us to enter style from layout. But we still have had to use quite a bit of time, since we are finishing layout ng at the same time as we're doing the container queries implementation. We've had quite a bit of time that we need to use for actually handling layout and legacy fallback issues. So we implemented inline size containment. Morten did that. And also we spent a bit of time improving the auto scroll bar implementation. This is the case where scroll bars take up space. There were existing bugs in the auto scroll bar implementation that were more prominent when we introduced more complex content inside overflow containers due to container queries that could make it easier to show those bugs. Another thing that has taken quite a bit of time is animations. So since computed-style can be updated for the same elements multiple times during a lifecycle update, the existing animations code would trigger animations sort of halfway through, which caused observable bugs. And also starting animations too early. We moved the animations update to after layout to make sure that we were totally finished with the style update before triggering the animations, like transitions and animations. getComputedStyle, that has also been a slight challenge, because getComputedStyle normally just have to compute the style. There are a couple of cases where we need to do layout as well in the existing code, for instance, because we use the result value for widths. So we need to do layout to figure out what getComputedStyle should return for width. But with container queries where the style depends on layout, we have to extend that to also cover the cases where we need to do the layout to have the up-to-date style. So we have introduced a layout upgrade concept inside the getComputedStyle code, where we detect in the cases where we actually need to do the layout to have the correct styles. Shipping and onwards. We have sent an intent to ship for size media queries, the size container queries, which we target for M105. We have got 3 LGTMs for that. With that, we also ship container relative units, which are similar to viewport units, where you can have lengths depend on the size of your container. It's currently blocked on shipping layout ng table fragmentation, but we have hope that that will be ready for 105 as well. We decided to ship without layout ng printing support because we thought it would be explainable to the author that it currently doesn't work during printing, and otherwise we would have had to wait quite a bit longer to wait for the printing implementation in layout ng to ship. Some great news is that we are getting cross-engine support because both WebKit and Gecko have started the implementation of container queries. There's also a polyfill that we work on at Google to make sure that we can also polyfill at least parts of container queries when you during the time we don't have full engine supports in all browsers. There is a spec for style container queries where you can query the computed style for your ancestors. We decided not to ship that at the moment, but we are planned to implement at least behind the flag for custom properties in Q2. There are discussions going on with other vendors, and it has been a bit more controversial to do style queries. There's an element match container, which is not fully spec'd, but will give you the same functionality, similar functionality as window match media would do for media queries. So that's also on the plan. Yep, that's basically what I had. Any questions? There are a bunch of things, details I haven't covered here, of course. This is what I was able to push into the 25 minutes. Do you have any comments, Ian? Did I say something wrong about layout?
There we are. Yeah, no comments.
I know I did say I didn't use quite the correct terms in layout all the way. I'm pretty sure about that.
The overall gist was there. No one's got any questions? Dominic says great talk. Bramus says that he's very happy to see that size-based container queries are here.
Yep. People have been waiting for it, so. What are the perf characteristics? Yeah, that's an interesting question. We did add a pretty deep nested container query thing to WPT that looked quite okay. Compared it to WebKit, and the Chrome implementation was quite a bit faster. And also, I know that Miriam, who's been doing a lot of the spec work, has also had some stress tests that looked okay. But we have not done like a very detailed performance analysis of it.
Yeah, we haven't done any like micro optimizations.
No, there are probably optimizations to be done in the style code for the setup of the style recalc.
Mm-hmm. Yeah, the sort of perf characteristics are relatively good. Because like, you know, so as Rune explained previously, we'll only like recalc style until we hit a container and so we won't recalc style for that subtree. So compared to, say an implementation with a resize observer, with the resize observer, you'd have to recalc style for that whole subtree, lay out that whole subtree. Whereas with the interleaving approach, it's certainly not free to like switch between style and layout, but both style and layout cooperate in that they'll try and do as much work as is possible. So you can think of it as like equivalent of just doing a single style recalc and a single layout with a slight bit of overhead for every time you like jump in and out. There's like a little bit of a performance cost. But broadly speaking, that's not free, but it's also not super expensive.
You should take the major hit of the performance cost on the first time you lay out, as if so. I assume that the components in your page, at least on mobile, will rarely change in size, and then the performance overhead after that, doing interactions with your page, shouldn't add any like big performance hits.
Yep. Did that answer your question, Eric? Great.
Yeah, I guess we're out of time. I'm not sure how long we usually continue before.
I think just until we've run out of questions. Is there any final questions? Yep.
Okay. Yep. Okay. Thank you for listening, and yep. Have a great BlinkOn the last couple of hours as well.